Good morning, Math 2. It's Mr. Hewitt. How are you guys doing today? All right, so today is Monday, April 13, and today we're going to be looking at solving systems of linear equations, word problems. Before we get started, though, I'd like you guys to take a moment, pause this video, and get all the tools that you will need for today's activities. So whether that's your pencil, your calculator, scrap paper, get all those tools, and also pull up your student-facing document on your computer. All right, so take a moment and do that, please. Thank you. All right, great. Welcome back, guys. So as I said, today we are going to be looking at solving systems of linear equations, word problems. It's actually a review because you guys have a mini QPA coming up on Wednesday, mini QPA number 2. And so I'd like you guys to pay particular attention to what we're going to do today. So there's a video linked in here that's also linked below that you guys should take a look at for additional examples, solving systems of linear equations, word problems. And let's just quickly review the steps. So the first step is to define the variables. Second step is to write the system of equations. And the third step is to solve the system using substitution or elimination method. All right, so let's look at an example of what that looks like. So here we have on page 3, turn to page 3 with me. So the example says that the admission fee at a small fair, let's back up a bit. Let's read the directions, always important to do. So it says for all problems, define variables, write the system of equations, and solve for all variables, okay? So here it says the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 collected. $5,050 is collected. How many children and how many adults attended? So how many children and how many adults attended? All right. So I'm going to stop sharing my screen with you right now. But quickly, the first thing you want to do with a problem like this is to define your variables. So if you look at this problem, right, the question first of all asks, how many children and how many adults attended? Well, obviously that's not given in the problem, and that's why that's asked here. So we could define our variables as A for adults and C for children, okay? Those could be our two variables, A for adults and C for children. In a minute, I'm going to write that on my whiteboard so that you can see, okay? The second step is going to be to write the system of equations that's going to enable you to solve this problem, all right? So based on the information given in the problem, you are going to need to develop a system of two equations that will enable you to solve this problem. And then the third and final step is going to be to solve the system of equations that you just made using either the substitution or elimination method. All right, so let me stop sharing my screen and let's do this problem on my whiteboard. All right, so there. Okay, there you should be able to see my whiteboard clearly. All right, now I'm going to demonstrate the problem on the board for you. All right, so we said step 1 is to define our variables, which is what we're going to do right now. So we are going to say A is for adults, number of adults. And we're going to say C is representing the number of children. Now, we don't know either of these. We don't know how many children, we don't know how many adults there are. So that's step one. Step two is going to be to write the equations, all right? So step two is going to be to write the equations. If we look at the problem, right, we are told that there were 2,200 people who entered the fair. So right off the bat, we know one of our equations has to be A plus C is equal to 2,200 or 2,200, right? That's obvious because it says it right there. It says on a certain day, 2,200 people enter the fair. So we know that the number of adults plus the number of children sums up to 2,200, okay? Now, the second equation, right, that we have to make in order to solve this is going to be based on the amount of money, okay? So if we look at the admission fee, it's $1.50 for children and $4 for adults. Now, usually we find the total cost for something by multiplying the price per unit times the number of items, right? So here we are going to multiply the number of adults by the fee for an adult, which is $4. So here I'm going to say $4 times A, the number of adults, okay, plus $1.50 times the number of children is equal to $5,050. Okay, the mere fact that the problem tells us the cost, the fee for an adult and the fee for a child, and also gives us the total amount collected, enables us to make this equation. So we know that the cost or the fee for an adult plus the fee for a child, all right, times the number of adults and children should give us the total cost. I'll say that one more time. The fee for an adult times the number of adults plus the fee for a child times the number of children is equal to the total amount collected. So now that we have our system, see we have two equations, we have our system, we can now go ahead and solve this system for A and C, okay? So step three is going to be to solve, all right? So we want to solve this. I say the easiest way is to use the substitution method. All right, I'm going to want to substitute something in for A or C and solve. But if I look at my top equation, all right, I don't have A or C's equal to everything else, all right? And that's what I want. I want to use this equation and plug it in for A or C. But before I can do that, I need to rewrite it so that it says either A equals everything else or C equals everything else, okay? It doesn't matter which variable you choose. You could choose to make it say A equals everything else, or you could choose to make it say C is equal to everything else, okay? I am going to make it say A is equal to everything else, all right? So I'm going to rearrange this. So I'm going to do that by subtracting C from both sides. And when I subtract C from both sides, I'm going to get A is equal to 2,200 minus C. Okay? A is equal to 2,200 minus C. That goes back to what you learned in solving linear equations. Okay? Now I can substitute this part right here in for A, okay? Now I can substitute that in for A, because that's what A is equal to. A is equal to 2200 minus C, okay? So I'm going to rewrite this equation, but instead of writing A, I'm going to write 2200 minus C. So 4 times 2200 minus C plus 1.5 C is equal to 5,050. All right, this is 4. All right, and so the next step, all right, so if you look at this equation, you'll notice that there's only one variable. Notice that we started out with 2 variables, A and C, adults and children. But here, I only have one variable, C. I only have C, which is exactly what we want, because we are only going to be able to solve this system if we can solve for one variable at a time. All right, so that's why we did this transformation with the first equation, so that we're able to plug it in for A and therefore have just C to solve for. Now, when we solve for C and get a number for C, we're then going to plug that in to solve for A, all right? Or we can use simple math here, because when we solve this for C, we're going to know what C is, and we already know what the total number of people is. So to get the number of adults, we're just going to be able to subtract the children from the total, and that will give us our adults, all right? So let's solve this for C. So we're going to distribute this 4. We're going to distribute this 4, and that means to multiply. So 4 times 2,200 is equal to 8,800. 4 times negative C, 4 times negative C is equal to negative 4C. And here we're left with what's outside here, plus 1.5. All right. So just remember that whenever you see a number like this, 4, to the left of something or things inside parentheses, you have to multiply the number outside by the numbers inside, number or numbers inside. All right, great. And that's a distributive property. All right, 1.5C is equal to $5,050. All right, we're getting closer. Now I can combine my like terms. I have negative 4C and 1.5C. Okay. So when we add that, should be 800. When we add that, negative 4C plus 1.5C, we should get negative 2.5C. And that's all equal to $5,050. And now if you look at this, right, here's my equal sign. Here's the left side of my equation. Here's the right side of my equation. I need to isolate C. I need to get C by itself. So I need to get rid of this 8,800. And I'm going to do that by adding a negative 8,800. Okay, to both sides. All right. So now it goes away here. Okay. And so here I'm left with negative 2.5C. And here I'm left with, now you guys can get your calculators and do that, right? So you're gonna put 5,050, take away 8,800, not the other way around. Okay, notice the bigger number is negative, so your answer is supposed to be negative. Okay, and when you do that, that should give you, let's see, 3450, 3,450. I think I'm right. Or maybe not. 3,750. Right? All right, great. And then we're going to divide both sides by negative 2.5. I think I'll need to get my calculator now. This is getting too much for me. All right, so you guys calculate this. So you're going to end up with C. All right, C is equal to whatever this gives you. All right, you're dividing a negative by a negative, so your answer is going to be positive. And what does that give you? Well, use your calculators. All right, guys, so when you divide 3,750 or negative 3,750 by negative 2.5, you should get positive 1,700. I'm sorry, positive 1,500. You should get C is equal to 1,500. All right, and so remember, C stands for the number of children, right? So if C stands for the number of children, then we know that there are 1,500 children. And remember, we also know that there were 2,200 total people. So how many adults are there? Well, adults will simply be the total 2,200, take away the number of children, which is 1,500, and that should give you 700. So there were 700 adults and 1,500 children. All right, guys. So just to recap, this type of problem is called a system of linear equations word problem because we have two variables, okay? In a typical linear equation, you have one variable to solve for. Here you have two variables to solve for, all right? And so we started this process by labeling or identifying our two variables. We said A represents number of adults, C represents number of children. Then we came up with two equations, or a system of two equations, all right? We were told that there were 2,200 people in all, or total. So, well, we said, okay, that means number of adults plus number of children equals 2,200, all right? And then we also said that, oh, since we know the fee for each adult and each child, and we know the total amount collected, then we can write another equation, and that's $4 times the number of adults plus $1.50 times number of children is equal to $5,050. And then we went ahead and we rewrote the first equation so that we're able to substitute it into the second equation for A. So we subtracted C from both sides to get A is equal to 2,200 minus C. And then we plugged that in for A and we solved our equation and we got C is equal to 1,500 children. All right, or C is equal to 1,500, which is the number of children. All right, and so we said that, okay, so to find the number of adults, we just need to subtract 1,500 from 2,200 and we get 700 adults. And we're done. The problem is complete. So to solve these kinds of problems, you have to follow this three-step process, okay? And let's take a look at the rest of today's packet. So we just did that example. The independent practice is on the next page, page 4, and you have 2 problems there. And also on page 5, you have an additional 2 problems. So your independent practice for today has 4 total problems, and these are all systems of equations word problems, and you should follow this 3-step process to solve these equations, okay? Remember, you have a mini QPA number 2 coming up on Wednesday. That will be similar to these types of questions. Okay. All right, guys. That's all I have for you. See you tomorrow morning at, you guys are math 2, so see you tomorrow morning at 10:30. All right. See you tomorrow at 10:30 for a live support session on Google Hangouts. The link to that is in Google Classroom, and see you there. All right, guys. So make sure you come on and ask questions if you're not sure how to get this done, or if you had a little bump in the road while doing this. Come on and ask your questions. Okay, don't just stay at home and cry. All right, don't stay home and cry. All right, guys. God bless and be safe. Take care. Bye.